Hello students, welcome to my chemistry class. Since lockdown is going on and usual classroom activities are suspended, I decided to share some of my classroom materials with you. I will be extremely happy if you find this helpful in your self-study. So today's discussion is about atomic structure and understanding the atom. So we know already that atom is the smallest constituent of matter. They are even smaller than the novel coronavirus, which is about 120 nanometer in size. Actually, heavier atoms are typically 0.1 nanometer in diameter. A nanometer is 1 billionth of a meter. Heavier atoms are typically like this, like gold atom, gold nanoparticle, this one. So we can say that atoms are actually nanoscopic, at least the heavier atoms. Have you ever seen such an atom? Well, today's technology fulfills our long cherished dream to see an atom, a single atom. For example, this image, this light is coming out from one single strontium ion. David Nardlinger, who traps ions in ultra-vacuum chamber for quantum computing study. Quantum computing, you know, it's a very hot topic today. So he shot this image by a DSLR camera, a single shot, a single strontium ion in DSLR. So this is the light coming out actually from charged strontium ion. We are very lucky that technology is so advanced now. But the 19th century physicists and chemists, scientists were not so lucky, obviously. The basic building blocks of atom were discovered by several European and American scientists with their beautiful minds and painstaking efforts. For example, electron, the negative part of an atom, negatively charged particle, were discovered through cathode ray tube experiments. J.J. Thomson determined electronic charge to mass ratio by experimenting the deflection of cathode rays. You see here the deflection of cathode rays in presence of magnet or electric field. And on the other hand, Millikan discovered by his famous oil drop experiment determined the charge of electron. Electron was named by another scientist, Stoney. Actually, in this oil drop experiment, these oil drops, tiny oil drops, yellow oil drops you see, are charged, and they are suspended between two capacitors, positive and negatively charged. The electrostatic force is balanced by gravitational force, and by this way Millikan was able to determine charge of one single electron. Cathode rays are the stream of electron actually. Okay. Now the other part, nucleus, positively charged. Electron was negatively charged and nucleus is positively charged. Total negative charge of electron is balanced by total positive charge of nucleus, we know, to maintain the electrical neutrality of atom. So nucleus was discovered through Ernest Rutherford's gold foil experiment, also a famous experiment. This blue block contains some radioactive element which emits alpha particles through this slit. There is a slit here, and this is the gold foil, about 0.004 millimeter thick. So alpha particles passes through the gold foil and produces scintillation here on the fluorescent screen. This is nothing but a fluorescent screen coated with zinc sulfide. Zinc sulfide is fluorescent material. So as soon as the alpha particle strikes the screen, a scintillation is produced, and by counting that scintillation, Rutherford and his students were able to perform this experiment to determine that something positively charged entity is there inside atom. Proton named by Rutherford in 1920. But nucleus also contains neutral particle like neutron. 1932, Chadwick discovered neutron by this experiment. Here also we see some radioactive element emits alpha rays. Alpha rays are nothing but stream of alpha particles. What are alpha particles? Alpha particles are actually charged helium ions. Those helium ions are striking a beryllium target. This is the beryllium target, and beryllium creates neutron. At that time nobody knew that it was neutron. Only Chadwick applied conservation of momentum principle. By using this paraffin wax, he applied some conservation of momentum principle to determine the mass of this blue particle. You see, the blue particle is hitting this paraffin wax, and paraffin wax is emitting this silver circle, that is the proton, and proton is detected and counted by this counter. So that is it. In this way, Chadwick proved that something similar in mass with this proton is emitted from this beryllium target, and he named this particle neutron since it carried no charge. It was neutral. Thus the existence of three basic particles of atom were proved by 19th century scientists. Okay, so we will see more in the next video. Thank you.